Hey guys, welcome to the first episode of Thresholds, where we'll be diving into one of my favorite small solar setups. This is a very basic setup that consists of a 100-watt photovoltaic panel and a 250-watt lithium power bank. This is one of the best threshold solar systems that gives you all of the essential elements of solar power in an easy plug-and-play system. Alright, let's take a closer look. Here's a closer look at the power bank, and you can see we have some MC4 connections coming from the panel that convert into a DC plug, which connects to the front of the power box. All plugged in, this is a pretty basic setup that can be anyone's first step to simple solar power. Okay, so we're at the bench here. It's time to talk about the main portion of the system, which is this Rockpal's 250-watt multi-purpose power station. Simply put, this is a battery, charge controller, and power converter, all packaged into a neat little box for use with our solar panel. I've had this box for about 2 years, and it packs quite a bit of functionality into a very small space. First, we notice that we have a charge meter on the side, which displays our remaining power. There's a sturdy carrying handle on the top as well. Now let's take a look at the front and back to see what features we have. When we look at the back, we have an on-off switch, the cooling fan exhaust, and 4 12-volt DC power supplies. Pretty simple. Taking a look at the front, we have 2 AC inputs, which are international ports, meaning that they'll work with AC appliances from around the world. Pretty interesting feature that you don't see with most solar power boxes. Next, we have our DC/solar input and 2 USB ports for charging. Now, looking at the other side, the box has some potential applications listed as well as some additional specifications. The box claims to be able to power CPAP machines, charge your phone, and a whole host of other outdoor equipment. We have 250 watts listed on both sides, and I'll explain just exactly what that means in just a minute. For now, let's take a look at some of the functionality of this thing. Great place to start is by turning it on. Alright, something must be working. We see that we have some lights on the side indicating that the unit is fully charged. Next, I'm going to show you a pretty cool piece of equipment that I have, which you might find very useful to purchase before you consider buying this entire solar setup. Now what we have here is a pretty straightforward AC watt meter, and basically what this device does is tells us how much instantaneous power an alternating current appliance is drawing. Okay, so next we're going to plug it into our power box and see how it works. On the front we have a backlit LCD screen with some zeros on it, indicating that we currently aren't drawing any power through the front of the unit. Well, that's no fun. Let's get some numbers on here. This is a simple way to show some of the utility this box can provide for you, and we're going to plug it into this battery charger. Ironic, I know, but it's something that's easy to demonstrate. So we're plugging into the watt meter to see how much power it draws. Okay, so we have lights on the charger coming in. It shows that we're getting good power flow, and in a couple seconds the power draw evens out to around 7.8 watts. Next, I'm going to talk about how this information can be useful for us in determining the capabilities of this little box. Alright, now let's get into some specifications. The Rockpal Power Box has several advertised numbers that each have different meanings in different contexts. Before we get started though, fair warning, this part's going to get somewhat technical, so get ready to learn about some solar power. Also, if you're a bona fide electrical engineer, I trust your comments will correct me where I go wrong. Okay, so in this box we have 222 watt hours, 60,000 milliamp hours, and 250 watts to work with on this unit. These are all common specifications you'll see, where watt hours and milliamp hours both represent battery capacity, while the wattage represents power. And since we're talking power, let's meet our friend, the power law, P=IV. This equation is from any basic circuit class that tells us that power is equal to current multiplied by voltage. Put that in terms of units, watts are equal to amps times volts. Now we have a couple of issues before we get started getting any useful information here. First, we need to clarify what type of electricity these capacity and power numbers are related to. On the direct current side, we have 60,000 milliamp hours of capacity. This is the same nomenclature that your cell phone battery typically would use. Next, our watt hours and power advertised are on the alternating current side. To clarify, direct current is the same type of power like from your USB port on your computer or your car's 12-volt power sockets. Alternating current, on the other hand, is the power like in your normal home outlet. In this power pack, power is stored in a 12-volt battery for DC use, but has to pass through a power inverter before it can be used in AC form. Now that we fully understand AC versus DC, let's get to the useful math part. To calculate watt hours that you might use with this box, it's as simple as multiplying the two together. To give an example of how you could determine what watt hour battery size you would need, you could fill out a table like this. We'll build a simple table with headers like so. Now, let's say that we have a TV that pulls 70 watts. We could determine this by the technical specs on the TV box or measure it with a watt meter like I showed earlier. We might use the TV for 1.5 hours on this box. Now we multiply the watts and hours, and we have our total watt hour usage. This is the same way that the power company calculates your power consumption each month, but usually in kilowatt hours. We can do the same process for a couple of other items like a lamp or charging our phone. Adding all the totals in this example, we see that we would use about 140 watt hours. Plenty of capacity left in our power box. Simply put, the more wattage you use for longer, the quicker your battery will drain. Now let's talk about how long it might take to charge our power box to full capacity. We'll remind ourselves of our friend, the power formula. This time we'll be solving for current to yield I = P over V. Important note before we continue is that our capacity is 60 amp hours and our panel operates at 12 volts in full sunlight. This is actually more like 22 volts in full sunlight, but that gets into a whole other conversation about potential and other technical jargon that would not only confuse me, but truly is not necessary for this video. Okay, so solve for current, we substitute our units like so. We have a 100 watt panel operating at 12 volts, which means that we have 8.3 amps flowing into the power box when it's plugged into our panel and we have good sunlight on the panel. Now for the last bit of math. We take our 60 amp hour capacity divided by the 8.3 amps and we estimate that it'll take about 7.2 hours direct sunlight to fully charge our battery. In my experience, this is fairly accurate. If I fully discharge the power box and then leave it in the sunlight all day, it will likely be charged by sunset. Some things that'll help make sure that your pack can stay fully charged each day are things like tilting your panel towards the path of the sun, that's to the south in the northern hemisphere, and making sure that it isn't shaded throughout the day. Alright, so you should be an internet expert by now about how to select a power box like this one to suit your needs. There's a couple things that we haven't covered, but to remind you, if you see watt hours, this normally refers to the AC capacity, while milliamp hours or amp hours is for DC capacity. Also, the 250 watts is the maximum power that the inverter will safely operate. So make sure that whatever you're trying to power doesn't exceed this 250 watt mark during operation. Some common things that will be well above this are things like power tools, microwaves, refrigerators, and your coffee maker. If you need to run more powerful things like this, you'll need a power box with an inverter capable of carrying that kind of load. For this box, some of the best applications are lighting, keeping devices charged, and things with very low power draw. This power box also includes an AC charger, so you don't actually need a solar panel to get some usage out of this box. But be careful how you plug this in, as there are 4 output ports in the back, and we don't want to use them. Instead, on the front of the panel, you'll see the DC solar input. This is where you'll plug in your panel or wall charger. Altogether, this setup is a great entry into solar power. With the panel only costing about $75 and the power box at $190, you have a simple and effective solar system for under $300. Please subscribe for more content like this, and don't forget to enable notifications to see our latest videos. I hope you enjoyed this episode of Thresholds. See you next time.